All right, boys, we're going to be looking at something called the trigonometric ratios. Now, what are the trigonometric ratios? It just means we are dividing two sides of the triangle. So the first ratio we're going to be looking at is the sine ratio. Okay, the sine ratio. It's a new word, the sine ratio. Now, what is the sine ratio? It's the opposite side divided by the hypotenuse. So if you come over to this triangle here, there's my angle, theta. This is the opposite side. This is the adjacent side. And this is the hypotenuse. Now, the sine ratio is the opposite side divided by the hypotenuse. Okay? So that means we take the opposite side, which is here. We divide it by the length of the hypotenuse. Okay? So the opposite side, opposite, divided by hypotenuse is called the sine ratio. And this is how we write it down. We write down sine theta equals opposite divided by hypotenuse. Now, we have to put the theta there. You can't just write down the word sine because you need to specify which angle in the triangle you're referring to, because you know that the opposite side is the side opposite to the given angle, the marked angle. So you have to specify the angle. You can't just write down sine. Now, we abbreviate this here, this formula. Sine is abbreviated as sin. Theta stays as theta. Opposite side is usually O, and hypotenuse is H. Now, in this triangle, the opposite side is 4, isn't it? So in this case, we would write down equals 4, and the hypotenuse is 5. Okay, so the ratio of the opposite side to the hypotenuse with respect to the angle theta is 4/5. We call that the sine ratio. Okay, so the sine ratio is the opposite side to theta divided by the hypotenuse. Now, what about the cosine ratio? Okay, now the cosine ratio is the adjacent side divided by the hypotenuse. So if I'm looking at the adjacent side, then let's just change the color here. So the adjacent side is this side here. Right, so the adjacent side, let's just get rid of the other ones here. Get rid of that. Okay. So the adjacent side divided by the hypotenuse is the cosine ratio. Okay. So now how do we abbreviate this? We abbreviate this as cos. Keep theta as theta. And adjacent is A and hypotenuse is H. Now in that triangle above, we have 5, of course, as a hypotenuse. Now if you look at the adjacent side, it's 3 centimeters. So the cosine ratio for theta is 3/5. All right, so the cosine ratio is the adjacent side divided by the hypotenuse. It's the length of the adjacent side divided by the length of the hypotenuse. Now, what about the last one, which is the tan ratio? The tan ratio is the opposite side divided by the adjacent side. Okay, and if we go back to our diagram here, and I'll just delete that and that. Now, it's the opposite side divided by the adjacent side. Okay, so that means I'm taking the opposite side to the angle theta and dividing it by the adjacent side. Okay, so the opposite side is 4 and the adjacent side is 3. So just coming down here, how do we abbreviate this ratio? Well, the ratio is abbreviated as tan theta equals opposite divided by adjacent. In this particular triangle, right? This particular triangle, the opposite side is 4 and the adjacent side is 3. So that means the tan ratio is 4/3 for the given angle theta. Okay, so those are our three ratios: the sine ratio, the cosine ratio, and the tangent ratio. Now, there is a way of remembering these three formulas. So if I write a little conclusion here, or a summary, now for the summary, we know that sine theta equals opposite over hypotenuse. Cos theta is adjacent over hypotenuse, and tan theta is the opposite side divided by the adjacent side. Now, there is a word which we use to remember this. So we take the first letter, S, right, and then the O and the H we write down as just O and H. Then we take the first letter of the cosine ratio, write down C, and then we take the other two letters, A and H. A and the H, put those together. And then last of all, we take the first letter of the tan ratio, T, and then we take the two letters remaining opposite divided by adjacent, and then we write that down. We say that as SOHCAHTOA. That's the way of remembering the formula. Sine is opposite divided by hypotenuse, cosine is adjacent divided by hypotenuse, and tan is opposite divided by adjacent. Okay, so that's our word, SOHCAHTOA, and we're going to use those formulas now for the next questions. Now, first example, we've got to find the sine, cosine, and tangent ratios for the marked angles. Now, here is my marked angle alpha. Okay, there it is. And what we're going to do is label the sides. This is the opposite side, this is the adjacent side, and this is the hypotenuse. Now, we've got to find the sine, cosine, and tangent ratios. Now, because we're using angle alpha, I'm going to write down sin alpha. So sine alpha is the opposite side divided by the hypotenuse, which is equal to 1 over root 5. 1 over the square root of 5. Now, we're not going to evaluate that because that'll give us a big nasty decimal. We're just going to leave it as 1 over root 5. Now, next one, cosine of alpha. So we write down cos alpha equals, that's adjacent divided by the hypotenuse. Now, the adjacent side is 2 over root 5. Okay, so the adjacent side is 2, the hypotenuse is root 5. The last one, tan alpha. Well, that's the opposite side divided by the adjacent side. So we write that down, opposite divided by adjacent, which is 1 over 2. Okay, so that's our three answers for the first example. Now have a go at part B. Now with part B, the marked angle is R. Okay, we haven't used the Greek letter, we're using the vertex for the angle. Here's the vertex. This is the angle we're talking about here. So you're going to write down what sine of angle R is equal to. You're also going to write down what cosine of angle R is equal to, and then what the tan of angle R is equal to. So let's first of all start off with the angle. The furthest side away is the opposite side. The side opposite the right angle is the hypotenuse, and the side next to the marked angle is the adjacent side. Now, I always write down the formulas so I don't make a mistake. Sine is opposite divided by hypotenuse, which is 6 over 10. right? Or you could simplify that to 3/5. Cosine of r, well, that's adjacent divided by hypotenuse. So just dividing two sides of that triangle. The adjacent side is 8 and the hypotenuse is 10. So 8 over 10. Or 4/5. And tan of r is the opposite side divided by the adjacent side, which is equal to 6 over 8, or you could simplify that to 3 over 4. Okay. All right, make sure that's all copied down, and then we're going to try this one. Complete the following for triangle ABC. So let's start off with sine of A. Now, sine of A, don't forget we're going to write the formula down, opposite divided by hypotenuse. So angle A is here. This is angle A. Now the side furthest away from angle A is the opposite side. The side next to angle A is the adjacent side. And then the side opposite the right angle is the hypotenuse. Okay, so the opposite side and the hypotenuse is 20 and 29. So we're going to have 20 over 29 for sine of A. Cos of A is the adjacent side divided by the hypotenuse. So that'll be 21 over 29. Tan of B. Now, got to be careful here because now we're switching to angle B. So I'll just change colours here. If we're looking at angle B, here's angle B. This side here, 21, is now the opposite side. So I'm just going to cross that off now and make this the opposite side. And the side next to angle B is the adjacent side now. So I'm going to cross that off. This is now the adjacent side, okay? Because we're talking about angle B in this case, right? Angle B. All right. Now, tan of B is the opposite side divided by the adjacent. The opposite side to B divided by the adjacent side to angle B. Okay, so the opposite side to B is 21. And the adjacent side is 20. All right. Now, what about sine of B? If we go to sine of B is the opposite side divided by the hypotenuse. Now, it's the opposite side to angle B. Opposite side to angle B is 21. The hypotenuse is the same, which is 29. Okay, so that's how to write down the trigonometric ratios, sine, cosine, and tan.